Hey everyone, and a huge, warm welcome to the channel. I truly hope you're having a fantastic day and that you're feeling happy, healthy, and ready to learn something new. It's always a pleasure to have you here, and before we dive into today's fascinating topic, I just want to send out some positive vibes to each and every one of you. Take care of yourselves, and let's get started on a journey into the amazing world of sound. Have you ever been swimming in a lake or the ocean, put your head underwater, and heard a boat engine or someone splashing around from what seemed like a mile away? The sound was probably incredibly clear and felt much closer than it actually was. Or maybe you've seen a nature documentary where whales are calling out to each other across vast, dark expanses of water. It makes you wonder, how can they hear each other over such incredible distances? Well, the secret behind all of this is a simple but mind-blowing fact. Sound travels faster and much more efficiently through water than it does through air. It seems counterintuitive, right? Water feels so much thicker and more resistant than the air we freely move through. To understand why this happens, we have to get to the very heart of what sound actually is. Sound isn't a thing that travels on its own, it's a wave of energy. More specifically, it's a pressure wave that needs to move through a medium, a substance made of molecules. Think of it like this. Imagine a crowded room full of people standing close together. If one person at the front pushes the person next to them, that bump travels through the crowd as a wave of movement. The people themselves don't all run to the back of the room. They just bump into their neighbor, who bumps into their neighbor, and so on, passing the energy along. Sound works in a very similar way. It's a chain reaction of molecules bumping into each other, transferring that vibrational energy from a source to our ears. So, for sound to move, it absolutely must have something to move through, whether that's a gas like air, a liquid like water, or a solid like a metal wall. In the vacuum of space, where there are no molecules to bump into, there is utter and complete silence. No sound can travel at all. Now, the speed of this wave, how quickly that energy can get passed from one molecule to the next, depends entirely on the material it's moving through. This is where the magic happens. The key factor is how close the molecules are to each other and how strongly they are bonded. In air, which is a gas, the molecules are spread out and flying around freely with a lot of empty space between them. When a sound wave comes through, it takes a little bit of time for a fast-moving air molecule to find and bump into its neighbor to pass the energy along. It's a less direct path. Water, on the other hand, is a liquid. Its molecules are packed much more tightly together. They're about 800 times denser than air molecules. Because they are so close, when one water molecule vibrates, it almost instantly bumps into its neighbor, which instantly bumps into the next one. The energy transfer is far more direct and efficient, like passing a message in a game of telephone where everyone is standing shoulder to shoulder instead of scattered across a giant field. This dense, close-knit structure allows the sound wave to propagate much faster. Let's put some numbers on this to make it real. At a comfortable room temperature of about 20 degrees Celsius, sound travels through air at approximately 343 meters per second. That's seriously fast, about 1,235 kilometers per hour, or 767 miles per hour. We're talking faster than a commercial jet plane. But in water, that speed jumps way up. In fresh water at the same temperature, sound travels at about 1,480 meters per second. That's over 4 times faster. In salt water, which is what fills our oceans, it's even quicker, at around 1,500 meters per second. This is because the salts and other dissolved minerals in seawater make it even denser, creating an even better pathway for those molecular vibrations to race through. This is why a whale's deep, low-frequency call can be heard by another whale thousands of kilometers away. The sound loses very little energy as it zips through the deep ocean channels. This principle doesn't just stop with liquids. If you think water is good, solids are the absolute superstars of sound transmission. Think about the old movies where a cowboy puts his ear to the train tracks to hear if a train is coming long before he can see or hear it through the air. That's not just a trope, it's real physics. In a solid like steel, the molecules are locked into a rigid, incredibly tight structure. The bonds between them are extremely strong. A vibration in one part of the metal is transmitted almost instantly to another part. Sound can travel through steel at about 5,100 meters per second, which is roughly 15 times faster than through air. Your own skull bones conduct sound to your inner ear better than the air does, which is part of why your own voice sounds so strange and deeper to you when you hear a recording. You're missing the bone-conducted part of the sound you're used to hearing. This property of sound is not just a cool trivia fact, it's something we use in critical technology every single day. Sonar, which stands for sound navigation and ranging, is the perfect example. A ship sends a ping of sound down into the water. That sound wave races through the water until it hits an object, like the seafloor or a submarine, and then it bounces back as an echo. By measuring the incredibly short time it takes for that echo to return, and knowing the exact speed of sound in that specific water, a computer can calculate the precise distance to the object. This is how we map the ocean floor, locate shipwrecks, and navigate in the dark depths. Marine animals like dolphins and bats use a biological version of sonar called echolocation. They emit clicks and listen for the returning echoes to see their world, hunting for prey and navigating through murky water or complete darkness. They are living, breathing examples of this incredible physical principle in action. So, the next time you take a swim or sip a glass of water, remember that you're looking at a substance that is an incredible superhighway for sound. It's a world of constant conversation that we are mostly deaf to, a hidden symphony of clicks, calls, and pings zipping back and forth all around us. It's a beautiful reminder that the world is full of hidden wonders, and physics is the language we use to understand them. Thanks so much for watching, and remember to be curious about the world around you. Until next time, take care and stay healthy.